Hello students, we were discussing the wideband code division multiple access specification and their architecture, network architecture. Today we will discuss little bit detail about the specification of this communication system, and we understand that the physical properties of WCDMA targeted the 3G communication, mobile communication system worldwide, and the physical properties we ended with the last module with the fact that there are basically two basic differences between a CRAN, basic differences between a radio access network as well as in the core network. And there is different modules, as I told in the last module, that in the different modules of this core network as well as the radio access networks, the different modules of the core and access networks, they will be connected via some links which we call as the interfaces, and all those links are named and they are classified according to the kind of the data that they are transmitting, the data traffic, or they are transmitting the control signal, or they are transmitting the management information. Based on that, they are classified. They are also classified, hence they will be giving a different kind of the names also. And followed by that, the figure 1 is basically depicting the different kind of the interfaces that we see in the UMTS or Universal Mobile Telecommunication System. And so the physical properties of a link between two network entities, any two network entities, they basically actually depends upon the signals that is getting transmitted over the link, as I told, and together with the function that it will provide with these signals. And you see the IW 1 to 4, there are different units inside the core network we saw earlier, and from here to actually to connect the UMTS core network or the ISDN network or the normal actually telecommunication network or other UMTS core network, the different kind of the interfaces we use, namely here we use either AU/GBU, here will be the NU, here will be BU, here will be the PU. So where the units, the core network units of the UMTS is getting connected to, based on that actually the interfaces, actually the pattern of the interfaces are also changing. Whereas actually from the mobile, inside the mobile station, we saw that in the mobile unit we are having the three different blocks or the three different identities, mobile terminal units and other parts. And inside that actually they are also having some terminals, having some interfaces in order to connect both of them. And in order to connect with the UTRAN, the main UTRAN system mobile station, to the UTRAN, the basic radio access network, you are having some kind of the connections and interfaces involved. So remember one thing, that what are the typical feature of each of these interfaces. If you wish to get details, further details of it, you have to have a look inside the specification document to get further details of each and every interfaces, which is beyond the scope of this discussion today. And UMTS was intended to basically achieve the global availability, and in order to do that, and they also tried to enable the roaming facility worldwide. So the coverage area in the UMTS was divided in some hierarchical layers. The layers that they thought actually, they thought that the bigger area that they will cover, that the layers that the bigger area will cover, there the capacity will be much higher compared to the second layers or the third layers, like that. And the biggest layer, worldwide coverage, which is the highest layer actually of the coverage, that will be also taking care or taking support from the satellites. So the different layers, if we try to see what exactly are they, so basically the three layers may be of it's not the worldwide, it's actually the three layers that I am making here. They may be actually named as the macro, then the micro, then the pico. And the macro, micro and the pico layers are the, if you try to see the comparison of this coverage area. It is something like this. Macro will have the coverage over a nationwide, micro will have your macro cells actually, or the whole nationwide you will be getting, whereas the micro cells will be having with the far distance positions where actually the communication is not reached, it is extension of that. And the pico will be having a zone inside actually some buildings or inside the house, inside the office premises. The communication that will be going on supported by the CDMA is called the pico coverage. So, it is not only the area, the reduction of the area, it is definitely the reduction of the area, but it also actually covers outdoor or indoor, remote or actually the close to the base station architecture. And remember, inside the building, not only the building, you can also consider that the hotspots are also part of the pico cells inside the airports, inside the train stations, everywhere the pico cells will be available. And in practice actually it has been though actually UMTS was first envisages to give a worldwide communication, but later on if you can see, you will see that there were the some other parts where the way it came out is like this. Initial phases only actually the very big cities were covered with a very few cells, and the large area coverages is achieved by the dual mode devices that can communicate either with the WCDMA or with the edge or with GPRS or with the GSM network. So, there were the dual mode devices associated with that kind of the communication. So, that is why actually whatever was promised and whatever was dreamt, that was in reality we could not achieve up to that, and different data rates and the service classes that it could promise finally. The maximal data rate and the highest supported user velocity were different from the different layers for each and every layers. For example, the macro layer, which is the biggest the highest layer, and they were supported 144 kilobit per second, because the coverage distance was much more, and up to speed that it could support up to 500 kilometer per hour. So, you will get a assured connectivity if you are moving with a velocity of up to 500 kilometer per hour. If you are in a micro layer, then the data rate will actually simply increase, because your distance covered has reduced. It is now changed from 144 to 384 kilobit per second, and the maximum speed of the vehicle with which you can move, as you are asking for the higher data rate, definitely there will be a restriction on the speed, which is basically 120 kilometer per hour. Let us see what is the target for the pico cells. In the pico cells, the user speed which was maximum 10 kilometer per hour, and hence we promised a data rate of 2 megabit per second, which is basically an indoor environment. So, it is a pedestrian speed that we can expect, or very low battery enabled cars suppose moving inside the airport zone, and there your 2 megabit per second data connectivity you can avail. And in the next slide we will compare actually the data rate promised by this UMTS with all other existing communication system. For example, the landline, the Wi-Fi, the GSM, and other some other proposals that came up under the umbrella of 3G under the 3G communications. And the maximal bit error rate and the transmission delay, which were grouped into the set out of which of the users, they can actually, based on the different kind of the configurations, now there is an option actually in the specification that maximal bit error rate and the transmission delay grouped together, you can actually have a different kind of the operation mode that you can choose as an user. First one is the conversational operational mode. What is that conversational operation mode? Is this class is mainly intended for the speech services, which is similar to the GSM. The delays for this type of this service was restricted up to 100 milliseconds, and larger values are experienced as unpleasant interruptions by the users, and bit error rate for this conversational mode, it should be in the order of 10 to the power minus 4 or less. So, conversational mode just supports the speech service like the GSM, with a delay of maximum 100 milliseconds, and it confirms that your bit error rate in the physical layer should be in the order of 10 to the power minus 4 or below that. Before going to the next class, as I was explaining in the last slide that this slide will continue with a comparison study of different kind of the existing communication systems. See here, this is the GSM, the black one, and this is the cordless DECT communication system. This is a mobile broadband system. This is WLAN. PSTN is a telephone network, landline networks, and here was the UMTS. So, the data rate wise, if I compare among all of them, so UMTS give around close to 1 to 1.5, 1 to 2 Mbps data rate. So, it is a data rate, it is not a megahertz, it should be Mbps, it is not megahertz, it is Mbps. And this is a mobility which is moving with a kilometer per hour. So, UMTS can support, as I have we have discussed in the last slide, that it can support maximum up to 500 kilometer per hour, and it can give you a data rate up to 2 megabit per second in certain environment. When your data rate high data rate means actually your speed is very less, close to the 10 kilometer per hour, and also you are very it is 1 kilometer or less. So, you are actually very close in the indoor environment to get a high data rate. As you are moving towards a very high speed, with a moving with a very high speed, your data rate is decreased. So, that is a common situation phenomena that we observed in the UMTS, but good part to compare is the data rate support, then the velocity support that UMTS can give, which was actually uniquely first time actually coming out from the wireless communication network, which was not enabled in the GSM or any other mobile broadband services, forget about WLAN and your landline. So, the data rate support along with your high speed, with a vehicular speed, was actually the very unique feature that 3G communication gave us. Moreover, actually the range wise, actually coverage range wise, if you try to see the way they could support the variable data rate as well as the variable coverage, it was also the unique concept that first time came when 3G came into picture. We will go back to the different class of the choice that your user can have in the 3G. We have studied about the conversational mode. Now, come to the streaming mode. In the streaming mode, in the conversational mode, it was the voice data traffic going on. In the streaming mode, you are streaming the audio and the video streaming, going ahead with the audio video streaming, and they are viewed as one of the very important application of the WCDMA, because first time it was introduced in the wireless communication, and the delays that actually was ensured, it should be in excess of 100 milliseconds, it can be tolerated, and the receiver typically buffers several seconds of the streaming material. Bit error rate and typically are very small, as noise in the audio signal is often considered to be a more irksome and then the voice and the telephone conversation. So, the bit error rate is very small, it is even below the 10 to the power minus 5, and that was the streaming. In the interactive mode, actually this category encompasses applications where the user requests the data from a remote area. So, it is basically the web browsing, I can call it will come under this class, and but also the database retrievals, the interactive computer gaming, they are all falling into this interactive class. And for this interactive class, actually the upper limits to tolerable delay is at same 100 to 100 milliseconds, not beyond that, because for even for web browsing or some any kind of the interactive games, the high delay damages the spirit, and bit error rate has to be lower, typically 10 to the power minus 6 or even less than that. So, background class is something that encompasses a service where transmission delays are not that much critical. For example, your emails and your short message services. So, short message services encompasses the portion where actually even if your delay is little bit higher, then you are not that much concerned about. Even the error wise also, the bit error rate wise also, that it is not that much critical. So, that is all about the different kind of the classes that we are supported, that is supported in the WCDMA communication, and as a user you can actually select any one of them for a typical application, and you can have the flexibility to choose any one of them out of a classes defined. AR interface here is, if we are going through it, is frequency bands and the duplexing modes that we should be very interested about. It utilizes the frequencies in the range of 1900 megahertz to 2025 megahertz for your uplink, and 200 megahertz to 2200 megahertz for the downlink. And within these bands, for the dedicated subband, there is a dedicated subband for the mobile satellite services, and the satellite service uplink uses the band up to your 1980. So, starting from 1900 to 1980, and it starts from the 1980 to 2010, and the downlink actually starts from the 2170 to 2200. So, whatever the bandwidth left, that is actually operated by the two modes of the terrestrial operation, either UMTS TDD mode or UMTS FDD mode. So, it is divided, basically the whole available bandwidth is basically divided into the mobile satellite service as well as the UMTS TDD FDD modes. So, that is a very unique feature that we have never seen in the second generation or the GSM networks. And if we try to see whatever we have learned in the last slide, so we have the capacity like this, and we have the frequency plan like this, and we are using the MSS UMTS MSS in this zone for the downlink. Here is the MSS zone for the uplink 1900 to 1980, and DSET you propose to use some bands close to here. DCS 1800 uses uplink and downlink in this zone. So, compared to all that, actually your UMTS provides actually much larger facility, and rest of the stuff whatever is left in the downlink as well as in the uplink situation, we understand that it will be utilized for UMTS FDD as well as the TDD mode. So, here is the UMTS FDD frequency range of the use for the uplink. It will be 1920 to 1980, and here it will be 2100 to 2170 for the downlink. TDD mode does not distinguish between the uplink and downlink, because here you are actually differentiating the uplink and downlink communication by some different disjoint time slots, and so it does not require any symmetric frequency bands and all, because there is no overlapping at all over the frequency bands, because time is different, transmission time itself is different, and provides orthogonality between the transmissions. So, where we use FDD, where we use TDD, if we try to see quickly, we will be able to visualize that this FDD operating mode, it was intended to use for the macro cells and the micro cells. TDD was intended to utilize in the pico cells. Remember one thing, if you are having a TDD mode, no, it is very difficult to handle very large propagation delays, because between the mobile station and the base station. So, you cannot use actually the TDD mode in the outdoor communications. So, TDD mode is always preferable to have application over the pico cells, as if the propagation delay is very large. Why you cannot actually it is difficult to detect, because if the propagation delay is very large, then actually two consecutive time slots where downlink and uplink transmission is going on, they might be overlap also. So, the part of the communication from the downlink will be overlapping over the part of the communication in the uplink. So, that way you can never be able to segregate the two signals in the downlink and uplink, and it is very difficult to handle. So, that is why we prefer to use actually the TDD mode of communication to an environment where it is ensured that the large propagation delays will not be occurring, which is basically the indoor environment. TDD also supports another very nice stuff. It supports if you the data in the downlink as well as in the uplink, they are the asymmetric data associated with, and hence the throughput is asymmetric. TDD can nicely handle it, but if the throughputs are asymmetric, then actually it creates a huge problem for the FDD model to allocate the channel and the different resources of the network to support that asymmetric throughput. So, this asymmetric throughput is actually very important part for your different application. For example, when you are doing web browsing, most of the cases we prefer to downlink rather than uplink. So, the throughput in the uplink in the web browsing is much higher than the downlink and the uplink. So, you will prefer to use the TDD mode when you are doing the web browsing. So, hence you see, based on the kind of the application you are doing and the kind of the difficulties associated with those applications, we prefer to allocate the users as a TDD mode or the FDD mode. And for medium access, when it is a TDD mode, time division duplexing going on, the medium access technology will be the joint detection time code division multiple access. And if it is a frequency division, if it is a FDD mode going on, definitely we will prefer to go ahead with the WCDMA or wideband code division multiple access based mode, multiple access based transmission mode. So, that is all actually about the fundamental understanding of what WCDMA is about, what are the typical features of this WCDMA, what are the interfaces, what are the different mode of the operations, where are the frequency channels, allocated bandwidths, and in what situation what kind of the different mode of operations are applicable, and what kind of the medium accesses will be sufficient and will be justifying the kind of the application we are preferring to do. And most important thing, this is the first time actually in the WCDMA we are going to support the voice, video, audio, as well as for example, this is a multimedia support. So, voice, video, data, and your web browsing, all supports are supposed to be there. So, you have a maximum flexibility in the WCDMA system to go ahead with a multiple class of the choice of operation based on the bit error rate requirement as well as the time delay associated with it. And that is why we saw the 4 different class of the operation going on based on the kind of the operation, kind of the communication you are trying to do. For example, voice will be only related with the conventional with the conversational class, as well as actually streaming mode will be always associated with the audio video streaming mode, and hence their bit error rate requirements and the delay associated with them will be completely different. 2 other remaining modes for your web browsing as well as SMS transmission and your email sending, they are actually different from the previous 2 modes. And this is a very we could not go in details of this specification of this WCDMA. We are seeing actually the constraint of this course and seeing actually the time limits associated with this, and but it does not stop you to explore the different kind of the specifications. You can open up the 3G specification, WCDMA specification, or any trans any good book or technical document available over internet, as well as if you go into the IEEE mentor site, you will be able to get the 3G spec document, and please go ahead with it as per your interest. Please try to explore all the further details as you find it is interesting related to WCDMA.